Hello everyone, welcome to the next lecture in the subject CAD-CAM. So this is Mr. Suyog Patil, working as a System Professor in Department of Mechanical Engineering, Sharad Institute of Technology, College of Engineering, Edrao, Itsalkarji. So in this lecture, we are going to discuss the manual NC part programming, manual part programming of this numerical controls. First of all, we will see the part programming. What is mean by part programming? The numerical control part programming is the procedure by which the sequence of the processing steps to be performed on this numerical control machine, NC machine. Okay. Then here part programming is the procedure by which we have to follow the sequence of this processing steps or to be performed on this machines. Okay, this machine should perform this sequence of this operations. Also, this part programming involves the preparation of a punched tape or other input medium used to transmit the processing instructions to the NC machine tool. Okay, so that means in order to transmit these instructions to this NC machine tools, so we have to prepare a punched tape or other input medium such as magnetic tapes or other floppy disk or pen drives. Okay, so this part programming consists a sequence of the instructions on this NC or CNC machines. Then these are the two types of this part programming. There are two types. One it is called as manual part programming here, and second one it is called as computer assisted part programming, CNC. Okay, computer assisted part programming are used in CNC machines. Then again, in order to prepare this part programming, the programmer decides the order of this machining operations required to produce on a component. Okay, so that means this order of the sequence of the operations required to produce a component. Okay, so that sequence must be decided by this programmer. Okay, to decide to prepare this part program, and the choice of the machine tool and the cutting tool depends upon this operations. Okay, this choice of the selection of this tool as well as this cutting tool and the machine tool, it depends on this operation that we are going to perform. Then each line of the program is numbered in sequence, details of the operations are stated, and the xyz coordinates are also given in this program. Okay, this part program, this the number in sequence, details of these operations, and all these xyz coordinate systems are provided. Then next it is steps involved in this development of this part program. Okay, so these are the few steps that need to follow this development of the part program. So first of all, we have to prepare the process plan. Okay, we have to prepare a process plan and identify the machine tool required. Okay, so we have to identify machine tool, then choose the tool and select the drive axis as well as. Okay, so by selecting this drive axis and by selecting this tool, then we have to determine the machining parameters such as feed rate, depth of cut, then spindle speed. Okay, so once we decide these various parameters, then we have to make a job and tool setup plans. Okay, so once this tool setup plans are prepared, okay, then we have to decide this tool path. Okay, that means the tool should follow the path. Okay, and write the part program. Okay, once we decide this tool path, we have to write this part program. That means the sequence of the operations, then path, then parameters. Okay, then after that test the program. After that test this prepared program and validate it. Okay, after validation this should be documented and this program should be used for this controlling. Next one, it is methods of this NC part programming. Okay, so there are few methods, or here are this 5 methods of this NC part programming. One, it is called as manual part programming. It is also called as Z code. Okay, then second one, it is called as computer assisted part programming. It is called as APT. Manual data input system is there. NC programming using CAD/CAM. Okay, computer automated part programming. These are the few methods of this NC part programming. So in this video we will discuss this manual part programming in detail. So then again, types of this media. First of all, this NC part programming requires some input media. Okay, and this input media are, there are 4 types of this input media, and these are the punched cards, punched tapes. Okay, and then magnetic tape is there, magnetic discs are there, and then computer transmitted NC data. Okay, these are the few media types that can be used in this NC machines. Then first one, it is called as punched card. The punched cards are almost obsolete as an input media for this, and so this NC cards are nowadays it is obsolete. Okay, because of their some limitations, it is obsoleted. The standard IBM card, that is 3.250 in wide and 7.375 in long and 0.007 in thick, as shown here, is the dimensions of this punched card. Okay, then the hole size and spacing between these holes is precisely specified. Then each card contains a 12 number of rows. Okay, 12 number of rows holes are punched here, and 80 horizontal positions across these cards, across this length of this card. Okay, 80 number of holes are there. The common code used for the punched cards is binary decimal. Okay, binary coded decimal is used in this punched cards. Similarly, the code for each character is represented by defining two sections on the card. Okay, so again we can see here there are first section it is used for the letters, then this section is used for the numerals. Okay, and this is for the special characters if any. Then again this two separate sections, that is called as the first three rows. Okay, these first three rows are called as zero rows, and while this bottom 9 rows represents the digits 0 1 2 3 4 up to 9. Okay, so 1 2 3 4 up to 9 represent. Then again the letter symbols comprise this one digit and the digit entry. The numerals as well as these letters and the special characters are also used to provide this data. Then second one media, it is called as punched tape. The specifications for this punched tape are standard by the EIA, Electronic Industries and Association, defined these specifications of this punched tape. Okay, it is made up of the paper or paper plastic sandwiches, then aluminum also. The plastic laminates are also used for this punched tape. It is flexowriter reads and prints tapes at high speeds as well. Then data is entered by using standard typewriter keyboards. Okay, and it is converted into the printed output and performed tape. Then punched tape can also be generated directly from this output of the computer based on the NC programming system. We will see here, this is the example of this punched tape. Okay, we can see here it is a wound tape on which these holes are punched, as we discussed in the previous lecture. Okay, holes are punched here by punching machines. We can see here also, and these holes contains, or these holes are in the sequence. Okay, increasing sequence. The spacing of these holes is also fixed. That is 0.100 plus or minus 0.02 allowance is provided here. Okay, spacing of these holes. They similarly number of holes different, or the number of holes along these sections are varies 6, 7, 8 or 5 sometimes. That may depends on this sequential data. Okay. Similarly then the error allowed, the tape width should be 1.00. Okay, the tape width is also standard. Then this rows of the state holes utilized when the punching tape is there. Okay, these holes do not affect the coding. So this is the benefit of this punched tape. Okay, third media is, it is the magnetic. So it is made by a coating a polymer or a mylar film with an iron oxide coating. This magnetic tape is prepared, or it is formed by using this magnetic oxide coating or Mayer film. Then these tapes have high storage densities, that is 1600 to 6250 bytes per inch. Okay, it has a high storage density. Then this magnetic tape this tape use of these tapes are for NC are limited by this fragile nature of this media. Okay, also dirt, oil, dust can cause the read errors, and industrial areas having ferrous metal fillings. Okay, may affect this magnetic tape. Okay, magnetizer tools may affect and change this damage of this data on the magnetic tape. This is one of the limitation of this magnetic tape. Then magnetic disks. Okay, a more reliable magnetic storage device is called as magnetic disk, or it is the floppy has been introduced in this magnetic disk. The two sizes are commonly used, that are 5.25 and 3.5 inch are the two sizes are commonly used. But this 3.5 inch size stores more data and better protection is also there in this 3.5 size. And the latter CD-ROM or compact discs read-only memory is used also in this magnetic discs. Next one, it is computer transmitted NC data. Okay. In CNC systems, the MCU, that means the machine control unit, is replaced by the programmable mini computer. Okay, this MCU is replaced by this programmable small mini computer. The number of NC programs can be stored in this memory of the computer. Okay, so this is the benefit of this computer transmitted NC control. We can store number of this memory stored in the memory, number of the programs in the memory of this computer. Then after this NC instructions are stored, the computer performs all these basic NC functions automatically or very easily. Okay, so this is also benefit of this computer transmitted NC data. Then manual part programming. We will discuss this manual part programming in detail here. So to prepare a part program using this manual method, the programmer writes this machining instructions on a special form. Okay, it is called, and this special form is called as a part programming manuscript. Okay, this processing instructions are documented on a form and it is called as part program manuscript. This part program manuscript is nothing, is the set of these instructions. Then again, the instructions must be prepared in a very precise manner. Okay, because this typist prepare this NC tape directly from this manuscript. Okay, so this typist takes this data from this directly from this manuscript. So therefore, these instructions must be prepared in a very precise manner. Then again, this manuscript form for 2-axis point-to-point operations as well as for this 3-axis contouring machines. Okay, this would be different. Okay, that means for this two axis and for this 3-axis, the manuscript should be different. Okay, then again we can say this manuscript is a listing of the positions of the tool relative to the workpiece that the machine must follow in order to perform this processing. Okay, so this machine should follow this sequence of the operations and the tool must move, or this relative tool relative to this workpiece. Okay, this manuscript should contain this listing of the positions. Then the listing may also include other commands such as the feed, speed, then tooling, okay, and so on. And the punched tape is then prepared directly from the manuscript. So therefore precise data should be there in the manuscript. Then in word address format. Okay, so therefore in this manual part programming, different formats are available. Okay, different formats are available. So first one, it is word address format. This word address format uses alphanumeric data specifications. Okay, so alphanumerical data is used in this word format. So that means this is the numeric alpha, or this is the word used here, z is there, x is there, y is there. Okay, so alphanumerical data are used here. Each data value is preceded by a letter which indicates the type of that data and that it follows. Okay, this format is used by most of these NC machines, also called as the variable block format. Okay, so we will see it in detail here. So these are the words, okay, used in this word format and their functions here. So A stands for rotation about this x-axis, B stands for rotation about the y-axis, C stands for rotation about the z-axis. Okay, these are the functions and these are the letters used to denote this function. Then F is for feed rate command, Z is for preparatory commands, I is for circular interpolation, x-axis offset. Okay, similarly J, K are the y and z axis offsets. Then M is for miscellaneous commands, N is for sequence number is denoted by this N. Then arc radius is for R is for arc radius, S is for spindle speed. Okay, similarly tool number, T is used to denote this tool number. X, Y and Z are used to denote this x axis data, y axis data and z axis data. Okay, these are the words and these are their functions. So we will see this. This is an example of this word address format where this N stands for this sequence number. Okay, this X stands for about this X axis data, Y, Z, and this is the S1000. That means this is the S stands for the spindle speed. Spindle speed is denoted here. Okay, so this is the one format used for this part programming of this NC. Then second format is tab sequential format. Okay, so here this alphabets are replaced by the tab code. Okay, so this tab is used here. These tabs are provided here. Okay, and these tabs replaced these alphabets. Okay, then which is inserted between the two words. Okay, in between these two, these tabs are used or inserted. The MCU reads this tabs, reads the first tab and stores the data in the first location. Then the second word is recognized by reading the record tab. Okay. So example of this sequential tab format is shown here. So these are the tab sequence are used. Then next it is block address tape format. Okay. So in this block address tape format, subsequent NC blocks through the specification of a change code. Okay, this okay. So therefore, this change code follows this block and the sequence number. Okay, and it indicates the values, which values are to be changed relative to the preceding blocks. Okay, so therefore, it indicates the number of the value which we want to change or which we need to change. Okay, this is the block address type of the format. Next it is fixed block format. Okay, in fixed block format, no letter address of the tab code are used and none of the words can be omitted. Okay, so we can see here it is an example of this fixed block format. There is no letter and word is used. Okay, in each NC block, same length and to contain same number of characters are used. Okay, the main advantage of this type of the format is the whole instruction block can be read at the same instant instead of reading character by character. Okay, so this is the main advantage of this fixed block format. We can read the whole instructions in a same at the same time instant. Okay, so this format can only be used for positioning work only. Okay, this type of the format is used to for the positioning of the work. So we will see example. The feed and speed are the same for 10 blocks of the NC data. Okay, F and S must be coded in this each block. Okay, so therefore this is the example of this fixed block format. So we can see here this is one of the fixed block format. Okay, so decimal points are assumed here. Okay, so this first gives the sequence number. Okay, this gives the sequence number. Then second one, this gives the preparatory function linear interpolation. Okay, then next this plus 0.13750 gives this x-axis command. Okay, that means move plus 1.375. Okay, so this is the command. Then next it is for y-axis command. Similarly, next for z-axis command, there is no motion in the z-axis, so it is plus 0.0 plus 0.0000 is denoted here. Okay, next this 0800 stands for this feed rate command. Okay, and miscellaneous commands, if any, is denoted at the last. That is the coolant on off. Okay, the outflow that is denoted here in the last. Okay, so this is the fixed block format. So thank you so much.